Very good morning. The portion for the CAT 1 will be, sorry, CAT 2 will be up to this chapter. That is Biot-Savart's law to calculate magnetic field due to arbitrary current carrying elements. Last class we have discussed about, I think last two meetings we had, I don't know, one or two, I think one meeting. We are started focusing on the magnetostatic part. So the governing equations are Biot-Savart's law and Ampere's law. Here in this magnetostatics, the source element is charges, moving charges or current, charges moving at a constant velocity, or we can call it as a DC current. It may be a line current or surface current or volume current. Depending on the source, maybe you need to you need to consider line charge density or surface charge density, or sorry, guys, line current density or surface current density or volume current density you need to consider. So for discussion, last class we considered this example, a finite and infinite length of conductors. What will be the magnetic field produced by the current flowing through such elements? Out of these two formulas, first formula is for the finite case, another is for the infinite case. Be clear, first is for not for semi-infinite, it is for full infinite. Okay, both ends are at infinite. And alpha 1 and alpha 2, how it's measured, look at this picture. Alpha 1 is measured, it is the angle measured between. Please, without understanding this, you can't solve any problem. See, the alpha 1 is the lower angle, or it represents the lower edge of the wire, alpha 1. It's measured between the axis of the wire, this is the axis of the wire, and the vector connecting the observation point and the lower edge. Same way, alpha 2 is the angle measured between the axis of the wire and the line connecting the upper edge and the observation point. These are the important points you need to understand, alpha 1 and alpha 2, how it's measured. Apart from that, A phi, that is the resulting magnetic field. Using your right hand, you can predict the direction of magnetic field. Last class we had some examples. Mathematically speaking, how to calculate A phi? You can calculate the resulting direction of magnetic field due to any current distribution using this equation. A phi equal to it's a product of, or you can see the resulting direction of magnetic field is a cross product of direction of the current A and subscript L, means the first vector represents the direction of current flow, and the second vector is a vector connecting the source, this is the source, and observer, source and observer. So we can generalize like arrow. Okay, arrow means, see, to calculate the direction of magnetic field, it's a cross product of the two unit vectors. First unit vector is represent the direction of current flow, and the second vector represent the vector connecting the source and observer. Unit vector connecting source and observer. Now let us try two problems and we can understand all this. So for this CAT 2 exam, based on these two equations, you can solve any problem. Not only these two equations, also this general equation. So if the given current distribution is somehow arbitrary, then you can go with this. If it is a straight filament, then you can go with this, either this or this equation. Depends on it is finite or infinite. Please take your notebook. So without pen and paper, it is not possible to solve this. Please try this. I'll give off minute time. Please sit with the notebook. Meantime, please go through the statement. Okay, I'll give some time. Okay, consider a theoretical loop, a conducting triangular loop shown in this picture carries a current of 10 ampere. So this you can see it's a triangular loop. The direction of current flow is represented with the arrow mark. So current is flowing in the counterclockwise direction. And for in the exam, suppose if you are asked to calculate what is the total magnetic field produced by this loop, then you need to decompose this into a simple problem. We don't have formula for magnetic field due to a triangular loop, but we know the formula for magnetic field due to straight elements, straight current carrying elements like 1, 2, 3. Okay, so we can calculate the magnetic field produced by the uh, segment 1, magnetic field produced by the segment 2, and magnetic field produced by the segment 3. This way we can calculate. So if any arbitrary shape is given, then simplify this into known or simple configurations. Now in this problem, you calculate only the magnetic field due to side 1 and 3. Now we are going to calculate magnetic field due to side 1. This is side 1 and this is side 3. Magnetic field produced by side 1 and side 3. And the observation point is at 0, 0, 5. Now, now let us start. Now first redraw this picture. This is Z, X, this is Y. We need to consider this segment. First, let us calculate magnetic field. First, let us consider side 1. So this is side 1. And the observation point is here. It's at 0, x0, y0, and z5. So this is the current carrying element, and this carrying current is flowing in this direction, and this is 0 and this is 2. Now out of the three formula, see, out of this like a general formula, these are three formulas. This is what I meant to say, three formulas. Like out of three, we no need to go with this general formula, because that length of the current element is finite. So you can use this formula, equation 2 you can use. So that the equation is already written in this page slide. Now you need to calculate this rho, alpha 2, alpha 1, all this stuff you need to calculate. So you need to calculate cos alpha 2, cos alpha 1, and a phi. Also you need to calculate rho. So all this you need to calculate. So problem will be completed. So that problem will be completed. Now what is rho? What is the radial distance between the observer and source and observer? That is the radial distance rho, right? So what is the radial distance?
5, sir.
5. Good. 5 is the radial distance. See, this is a line. The black line, it's a line that is carrying current, and the radial, this is the radial distance. This radial distance is 5, right? So rho equal to 5. One part of the problem is solved, right? Done. Rho equal to 5. Next, we need to calculate alpha 1 and alpha 2. Where is alpha 1 and alpha 2? I will delete this rho part. Okay, now where is alpha 1? What is alpha 1? What is the angle alpha 1? How to calculate alpha 1? Alpha 1, I'm repeating, alpha 1, this is the lower edge, right? This is the lower edge, this is the upper edge of the wire, okay? Or upper limit, and this is the lower limit. Now draw the axis of the wire. This is the axis of the wire, right? So wire is along the x-axis. What is alpha 1? Alpha 1 is the angle between the axis of the wire. Yeah, this is the dotted line. Blue dotted line is the axis of the wire, and the vector connecting the observer and the lower edge. Now I'm highlighting it with blue color. Okay, so the vector or the line connecting the observer and the lower edge. Okay, so this angle will be the alpha 1. So now tell me, what is alpha 1? So angle between this blue dotted line and the solid blue line will give you the alpha 1. What is alpha 1?
Angle between that
Yeah. Yeah, what is the angle between that X and this
dotted line and that
solid blue
observed
line?
line.
Yeah. For your reference, I will show this picture again. So this is alpha 1. How we are measure angle between the axis of the wire and the line connecting the observer and the lower edge. Yeah, without using pen and paper, you can give the
Pi by
answer.
2, sir.
Pardon?
Pi by 2.
Yeah, exactly. Correct. It's 90 degree. But still, some of you think like it is not 90 degree because of the way we are drawing. See, this x angle between the x and y and z, this is orthogonal coordinate system, right? So this dotted line is along x-axis and this solid blue line is along the z-axis. So the angle between x and z should be 90, but it's not look like 90. That's why you guys thinking it's some other angle. So it is alpha 1 equal to 90 degree. So always you think like if they are aligned with the axis, then it should be 90 degree. Between one direction and other, it will be 90 degree. Okay. This is clear. Alpha 1 is 90. Now let us calculate alpha 2. What is alpha 2? Alpha 2 is the angle between the axis of the wire. So this is the axis of the wire. Let's continue. Axis of the wire and a line connecting the observer. This is the observer and this is the upper edge of the wire, right? So you connect the observer and upper edge of the wire. So this is green line. Okay. So this is the axis of the wire, dotted green line. So this angle is alpha 2. Alpha 2 is the angle between the axis of the wire and line connecting the observer and upper edge. This is alpha 2. How much is alpha 2? So alpha 2, so don't directly calculate alpha 2 angle, it's not required. Anyhow, we need to replace this, this term alpha 2, cos alpha 2 is required. So directly calculate cos alpha 2. So what is cos alpha 2? See, you clearly first you mark this, then only you can able to do this. So this is 90 degree. This is the right angle, right? So this is alpha 2. Now you can say cos alpha 2. So cos alpha 2 is, what is adjacent side? What is the length of the adjacent side? What is the length of this black line? It is 2. See, this is 2.
1 by 2.
No, this one. This length is 2, right? This is 2.
Yes.
Right? Over square root of, so what is this length? This solid green line. So this is square root of 2 square plus this length. This length is, what is this length? This length is 5. So it is 5 square. So which is equal to square root of 29. Okay. 2 over square root of 29. Is it clear, or if you don't understand, I'm ready to repeat. This
Yes.
part alone, okay, you consider this part alone. This is 90 degree and this is 2 and this is 5. So this is square root of 2 square plus 5 square, it is 29. This is alpha 2. This is what we want to calculate. So cos alpha 2 is 2 over square root of 29. Now, if you want, we can write this answer. H vector is equal to, what is I? I is 10 amps divided by 4 pi rho. Please listen to the screen. 4 pi into rho. Rho is 5. Uh, cos alpha 2. How much is cos alpha 2? Cos alpha 2 is 2 over square root of 29 minus cos alpha 1 is cos 90 degree, right? Alpha 1 is 90 degree. So cos 90 is 0. Okay, so this is also correct. So do you think that problem is completed? See, if you stop with this step, you will not get full mark. The reason is that you have expressed the answer in terms of phi. It is in the, see this formula, whatever, or the equations, whatever we have derived, that we did based on the cylindrical coordinate system, right? But this problem, see what's given, it's given in the rectangular coordinate system. So you need to rewrite this answer in terms of rectangular coordinate system. So rewrite or express this a phi in rectangular coordinate system. So can you please say what is his answer? At least let us first calculate the scalar part. How much it is? It's supposed to be 59.1. I have the answer ready. 50, sorry, 50.
Minus.
No, no, not minus. It should be plus. How we are getting minus? It's 59.1. See, some of you tell minus. Can you say why you are how
Also,
we are getting minus?
in the previous step, you wrote it as calculated it as minus.
Sorry.
Nothing. So this one is right.
Okay, okay. So this is the answer. Now we need to express this a phi in terms of, or we can say you need to express the magnetic field direction in Cartesian coordinate system. Please listen to this carefully, the procedure. So already I gave one shortcut. Now let us apply the shortcut. Listen to the screen. Direction of magnetic field, that is a phi in terms of cylindrical coordinate system. Now we want to write it in the Cartesian coordinate system. What is the formula? AL vector cross A row vector. What is AL vector? AL vector is the unit vector along the current direction. Okay, AL vector is the unit vector represents the direction of current flow. In this picture, I am talking about this picture. In this picture, what is the direction of current flow? In which direction current is flowing? It is flowing in the positive x direction, right? Cross product with the unit vector which is connecting the source and the observer. So go in the proper order because it's a vector. What is the unit vector connecting the or representing the source and observer? This vector, right? This is a radial vector. This is a radial vector. 5 you took it is 5, right? So this is the radial vector or vector connecting the source. This is the source and this is the observer. Green dot is the observer. So it is, at least you tell the answer for this. What is the arrow vector here? What is the unit vector connecting the source and observer? What is the radial vector connecting the source and observer?
AC.
Yeah, AZ, right? So AX cross AZ will be, now use this cyclic rule, X, Y,
Minus.
Z. Okay, so X to Z, so it is minus Y. Okay, so as per this given, as the problem is given in the Cartesian coordinate system, you need to write the answer like H vector is 59.1 along minus Y direction. This is what I expected. Even this is correct, but this answer is in cylindrical coordinate system. You need to write it in the Cartesian coordinate system. So magnetic field due to this segment 1, at the observation point, this is, please look at this picture. So at this point is minus AY. Now it is a time to cross check the answer. Why it is something along minus Y direction. Now let us not bother about the scalar part. Now let us see why it is minus along Y direction, minus Y direction. It's very easy. Assume that at this blue dot, you are standing there at the blue dot. You are the observer, right? Now, this is the direction of current flow. This is the direction of current flow. If the current is flowing in this direction, use your right hand and use your thumb to represent the direction of current flow, and these remaining 4 curved fingers will represent the direction of magnetic field, right? So what is the direction you are getting? This is the direction, right? So this will be the direction of magnetic field. Sorry. Right? So if you take any point like anywhere, so magnetic field is going downward. So in this direction it is going. So where you are standing here, right? So with respect to you, with respect to the observer, the magnetic field is passing in this direction, downward direction. Downward direction means it is in the negative y direction. That is why it is in the magnetic field due to the element 1 is along the negative y direction. Please speak if you are not able to get this why it is minus negative y, or else I will move to the other segment. We can discuss the other segment. Guys, is this clear?
Yes, sir.
Yes, sir.
Now I will give 2 minute time. See if you can complete this example, you can get 10 mark in cat and fact. But try the second, like the side one we have discussed. You got some clue, right? I hope you are comfortable with that. Now try for side 3. Now let us calculate magnetic field due to side 3. First calculate our cos alpha 1, cos alpha 2, rho. Only 3. And then finally A rho. Sorry, A5. Please proceed with all the other steps. Cos alpha 1, cos alpha 2, rho and A5. You calculate everything. Now let us start. Please stop wherever you have. Sir, really this need 3 minutes, more than 2 minutes, really no problem, will need more than 2 or 3 minutes. Now let us start with rho. Now let us first calculate the rho. What is the radial distance? So before that, you just mark these points. It is actually at 2, right? Sorry, it's not 2, it is 1. And this is also 1, correct? Yeah, this is also 1. Now let us, and observation point is here, it is 0, 0, 5. Now the radial distance between the wire and the observation point. What is the radial distance? What is the radial distance?
5, sir.
Yeah, it is 5. The radial distance, I'm not asking about the distance between the edge and lower edge and this point and upper edge and this point. It is a radial distance. So radial distance means it will be always same, right? So this will be rho equal to 5. Okay, so radial distance means you need to calculate between these 2 points, rho equal to 5. Next is cos alpha 2. To find cos alpha 2, I will highlight the axis of the wire using dotted blue line. So this is the axis of the wire. Now, what is the angle between the this blue axis, dotted blue axis, and this z axis? Let me say this solid blue line. What is the angle? What is the angle alpha 1? Pardon? See, this dotted line is lying in the xy plane. This dotted line is lying in the xy plane. I'm asking you to calculate the angle between the dotted blue line and solid blue line. Now you give the answer.
Sir, 45.
See, while solving this problem, this will be the issue. Generally, all you will face this issue. If you draw this, if you look at this picture, you may think like it is some 20 degree or 30 degree or 45 degree. That is not at all correct. This is a 3D picture. We are doing it in 2D. That's why you will into all this confusion. Yeah, why it is 5/2? Why it is not 45? Guys, please understand. Please, yeah, please. Give your answer.
Because it's lying in the XY plane and it's perpendicular to Z.
Exactly, guys. This dotted line is lying in the XY plane, right? And Z is perpendicular to the XY plane. So this will be 90 degree. This is 90 degree. It is difficult to show it in this picture, okay? But it is difficult to even recognize that is 90 degree if whatever the way you draw. But maybe maybe in 3D if you show, you can have a better picture. But it is 90 degree. Is still anybody not convinced it is 90 degree? See, it is like it is in the front wall. This black line is in your front wall. Okay. So what is the angle? Like, yeah, it is in the front wall, and you know this z axis, or let us say this is the point lying in the your left side corner, right? Edge. Okay. So the angle between these two should be 90. I can say this. I think now it's better, right? It is 90 degree, right? This is 90. This is also 90. Now moving to alpha 2, cos alpha 2. What is alpha 2? See, if you can't able to understand this, or you need little imagination, especially with this 90 degrees, you need to have little imagination. Now it's about alpha 1. So alpha 1 is the angle between the axis of the, sorry guys, it is, I think there is a mistake. Lower edge is 90 degree, right? Sorry, lower is 90, cos alpha 1. So cos 90 degree it is 0. Now we need to calculate cos alpha 2. Alpha 2 is the angle between the axis of the wire and the line connecting the observer and the upper edge of the wire. So this angle is alpha 2. This angle is alpha 2. Let's stop with this. If any problem in identifying alpha 1 and alpha 2? If you have doubt, you need to speak, otherwise I will move to next step. So alpha 2 is the angle between the axis of the wire and the line connecting the observer and upper edge of the wire. Alpha 2 you need to calculate now. So it's like it's a right triangle. Now you know this length, you need to calculate the length, right? What is this length? What is the length of this black line? What is this length? If I draw, it will be messy. You need to tell this answer. What is the length of this black line? Root 2. Yeah. Why it is root 2? Because it is 1. This is 1. Right? This is 1. So this length will be square root of 1 square plus 1 square. Right? So it will be square root of 2. Root 2. Right? And what is this length? This length is 5. Then what is this length? What is the length of the green line? It will be 5 square plus
29.
root 2 square. It will be square root of, no, not 29. Square root of
27.
27. See, the length of the black line is square root of 2.
that we have calculated from the this already this detail is available, right? So this is one, so it will be square root of 2. That's all. Huh? Now you can calculate cos alpha 2. So now tell me, give me the this is right angle, guys. This is right angle. This is alpha 2. Now what is the angle for cos alpha 2? Sorry, what is cos alpha 2? Give me the formula.
Root 2 by root 20.
Yeah. Adjacent by hypotenuse. So root 2 over square root of 27. So cos alpha 2 we have calculated. And then maybe at the end we can plug all this. Okay, so rho we have calculated, cos alpha 2 just we have calculated, cos alpha 1 also calculated, it is 0. Now it is the time to calculate A5. Any questions until this 3 steps? Rho calculation, cos alpha 1 calculation, and cos alpha 2 calculation. Merely even most of the magnetic it will be merely a trigonometry kind of problem only. Without using pen and paper, it's not possible to find anything, impossible, because these are two angles you need to calculate. That's the problem. Now, let us calculate A rho for A5, direction of magnetic field. What is the general formula? Unit vector representing the direction of current flow, and the vector is a radial vector connecting the source and observer. Right? Now, question is, what is AL vector? Yeah. Now, please find AL vector. Now, I don't want to mess with this picture. I will draw it separately. Now, what is AL vector? That's what we are going to find. So, this is the current element. So, current is flowing in this direction. So, you need to write the vector, unit vector for this red segment. What is the unit vector for this red segment? AL vector. Okay. Now, let us write. You know, this is, what is this length? This length is 1. This length is 1. So, this is AX. Right? This is AX. What about this? This is AY. You can say this is AY. Right? Because this height is 1, right? So, it is AY. AX, AY. Now, the question is, what is this red segment? A solid red segment, red line. You complete the unit vector equation. Sorry, you know the vector addition, right? So, what will be this A rho vector? So, this is, sorry, this is not A rho, it should be AL. What is AL vector? So, AL vector represents the current flow, direction of current flow. Now, give me the equation for AL vector. Please, whatever it is, you need to give the answer. Come on, speak. You need to apply the head tail rule. It is AX plus AY. How many of you think it is AX plus AY? Or it is some other answer? Okay, leave it directly. I will write the answer. It should be minus AX minus AY. The reason is, like sum of this vector and this should, this horizontal or tangential and normal will yield in this AL vector. Okay, so this vector, it is in the minus AX direction, so this minus AX, again in this way if you go, it is in the minus Y direction. Okay, so sum of this vector plus this vector will give you this vector. So minus AX minus AY will give you you can get AL vector. Now A5 equal to, let us compute. AL vector is minus AX minus AY cross product with arrow vector. What is arrow vector? This is zero vector, like vector connecting the source and observer. This is zero vector. So it is along the z direction. So if you cross product this, then you will get ax cross az. First two times if you take the cross product, so use the cyclic rule. Ax cross az, ax cross az, you are going in the reverse direction. So that will be a minus. Already there is a minus, so it will be plus. Ax cross az will you will get plus ay. Minus and minus will get cancelled, right? Then ay cross az. Ay cross az, you are in this order, cyclic order. Then it will give you the plus ax. Already there is a minus sign, so it is plus ax. Already there is a minus. So the direction of magnetic field is ay minus ax. Now you can put all the values. A5 you have calculated. You have calculated rho. You have calculated cos alpha 1. You have calculated cos alpha 2. Now you can plug everything, and finally you will get this answer. So this clear, I will move to the shift. If there is no questions, I will shift to the next example. Now we have calculated for side 1 and side 3. Maybe in the exam you will be asked to calculate for side 2. So if it is 10 mark question, like the 3 sides will be given and you will be asked to calculate for the 3 sides or 2 sides depending on the length of the question. Now please try this. Find magnetic field due to this current element shown in figure. Look at this picture clearly. Look at these details. See, there are two segments, shape L, look like a shape L, and this vertical segment. What is the length of the vertical segment? Length of the vertical segment. It is infinite or semi-infinite. You can say semi-infinite
Infinite.
because one edge. Yeah, it is actually semi-infinite should be called as infinite. But you can see this one edge is at known end, right? Another edge is at the infinite, right? Infinite. Okay. So, and same way the other horizontal segment, this segment I am talking about, one edge is at the known end and another edge is at infinity. Okay. Now the question is, now let us first calculate magnetic field due to the vertical element. Element which is carrying current in the vertical direction or it's along the z direction, right? You need to calculate. Which formula will you use? Will you use the, I will go to the formula page. Will you use formula 1 or formula 2 or formula 3? Which will you use? Anyhow, we don't need to go with the general formula because it is a length, straight wire. So you can go with formula 2 or 3. Now question is, will you use formula 3 or formula 2? You need to use formula 2, you should not use formula 3 because the lower edge, that is alpha 1 is at some known, it is at our visibility, right? It is, but alpha 2 is at infinity, but alpha 1 it is available, right? So you should not put the condition like alpha 1 it is at negative infinity. Okay, by putting alpha 1 at minus infinity and alpha 2 is at plus infinity, we are getting this reduced formula. Okay, so you can't use this, you should not use this formula 3, rather we have to use the formula 2. Let's write the formula. I over 4 pi rho cos alpha 2 minus cos alpha 1, all this blah blah. Okay, now let us calculate rho. Now let us first fix this observation point. So this is the observation point, it is at minus 3, 4, 0. Take half minute and understand this picture. X-axis, y-axis and z-axis. Observation point is here. We are considering only this vertical element. Now our focus is only this vertical element. Now let us start with rho. What is the radial distance between the What is the radial distance between the vertical element and this red dot or observation point? What is the radial distance? See, this is this is 5, right? This is minus 3, and or you can say the length is 3. This length is 3, and this is 4, right? 4 along y dash. Now, what is rho?
5, sir.
Rho equal to, yeah, don't think rho equal to 4 because see, it is a radial distance we need to take. Okay, so if you don't understand, that's why I have inserted this kind of picture, right? It is like you are going to, if you are taking a cylindrical, here you are taking a cylindrical coordinate system, right? So the surface of the cylinder should pass through the observer. It is like it should pass through the observer. So what should be the radius of the point P? Radial distance of the point P, it should be square root of 3 square plus 4 square. That's 9 plus 6, so it's 5. Okay? If you have this cylinder, let me remove. Now, what is alpha 2? Now let's start with alpha 1. What is alpha 1? Alpha 1 is the, see, this is the lower, that is the higher edge, right? So what is the angle alpha 1? See, it's marked in this picture. I think this picture is very clear here, right?
90, sir.
So alpha 1 is the, and correct. Alpha 1 is the angle between axis of the wire and the line connecting the observer and the lower edge. So this red line, okay? So the angle is 90 degree. So cos alpha 1 is 0, sorry, 0, right? Next, alpha 2. What is cos alpha 2? Or you can say directly write alpha 2.
0.
Yeah, exactly, it is 0 because it is at infinity, right? As the angle increases, the angle will be reduced and it will reach 0 degree. Okay, so cos alpha 2, sorry, cos 0 will be 1. Now, what is A5? This is what the critical in this question. AL cross A or direction of current flow cross product with direction of the unit vector. Okay. Now, first let us radial vector, aero vector. Okay. Now, please give me the equation for aero vector. I will clean this page. I need to clean this page, otherwise it's difficult for me. Now, the focus is calculating the A5. So, it is AL vector cross A 5. Sorry guys, aero. Now, what is AL vector? In which direction current is flowing? What is AL vector in this picture?
Minus AZ.
Exactly, it is minus. Minus. You need to be careful with this. You may not notice the direction. It is negative. It is going in the minus is the direction. So that's correct. Now the question is, what is this vector? Aero vector. You need to calculate. What is aero vector? For your benefit, I will highlight that. So this is minus 3. So this is the observation point. Right. This is the origin. So this is minus 3 AX. And this is 4AY. Now question is this one, right? This is aero vector. What is this length? What will be this length? Guys, don't simply put aero equal to AX minus AX plus 4AY. That is not correct. This length is not unit length. This length is not unit length. We don't know the length. So we need to calculate the length. What is this length? Already have calculated. What is the length of this segment? This is the radial distance, rho, right? So rho equal to 5. Already have calculated. This is 5. Got it? Rho equal to 5.
Yes, sir.
Okay? Now write the equation. 5 into aero vector equal to, you can write any vector as a sum of two orthogonal components. Okay? 5 aero vector is minus 3AX plus 4AY. What do you want? You want unit length, aero vector. So aero vector is minus 3 upon 5 AX plus 4 upon 5 AY. Done. That's all. So you have calculated AL, you have calculated aero, just you have calculated aero. That's all. You need to do the cross product. So A5 equal to AL cross, I don't know, this, my space is not available. Okay. If you write the answer, let me directly write the answer. So A5 will be equal to minus AZ into minus AX. So minus of minus will be plus 3 by 5 AZ cross AX. AX, AZ cross AX. What will be the result? AZ cross AX. It will be AY. Same way the second term. So minus plus, so it is minus 4 by 5 AZ cross AY. AZ cross AY means it is AX minus AX. So this should be the direction of magnetic field. You need to be careful while calculating the arrow vector. Don't write it like arrow equal to this is minus AX and this is plus. See, because previous problem it was length was 1. So we directly took, but here the length is not 1. So this is not minus AX, this is minus 3AX. That's why you need to be careful with this step. Something was wrong. I think our answer somewhere we got some minus, right? What was the mistake? Now I can't go back to those things. Oh, sorry. While writing, there was copy and paste. There was error. See, rho into arrow vector is minus 3ax. This length is minus 3ax plus 4ay. Right. While writing in the next equation, I have inserted a minus here. Okay. I don't know where I did the mistake. Okay, maybe you can check it later. So, so this will be the answer. Now let us check this answer. Now let us try to understand this AX and AY. Because finally sometimes this kind of careless mistake we may do, so we can cross check this answer. It's very easy. See, this is a vertical element. So if you keep, if you use the right hand rule, then you can easily calculate the direction of magnetic field will be in this direction. So observer is somewhere here. So with respect to the observer, see in which direction, if you take the x direction, so it is along the positive x direction. If you take the y direction, it is along the positive y direction. So that's why the answer is along the positive x and positive y. Okay, in that way you can cross check. Now let us take one more, let us consider other element, horizontal element. Any questions with this?
No, sir.
Now consider the horizontal element. You no need to draw the cylinder, just for your visualization or for understanding. I have shown this. It is like we are considering cylinder coordinate system along this axis, but anyhow that's not required. Leave it. Now, as usual, first give me the value of rho. Now the horizontal element is highlighted with the green color. Now what is the rho? What is the radial distance between the horizontal wire and the observation point? What is rho? For your benefit only, I have inserted this cylinder. What should be the radius of the cylinder? And what should be the radial distance between the green line and the point minus 340? What is the radial distance?
Sir, 5 again.
Sorry? Repeat, please.
Sir, 5.
No, it is not 5. See, this is the 5. This is 5, right? This is what the radial distance. In this case, if you take this axis, this is the radial direction.
Oh, okay, got
This
it,
is the
sir.
radial direction, right?
4,
So
4.
it should be, yeah, it should be 4. Thank you. Now let us calculate alpha 1. I will delete all this. Now let us calculate alpha 1. Alpha 1 is the angle between the what is this? Observation point and lower edge. Angle between the axis, this is the axis. See guys, don't look at this alpha, this for the previous problem, okay? And this is the line connecting the observation point and the lower edge, okay? So this is alpha 1. So what will be alpha 1? So this is what alpha 1, right? It is alpha 1. You know this length is 3, this length is 4, this is 5. Now what is alpha 1? Cos alpha 1. You want cos alpha 1. What is cos alpha 1? And you know this is a right angle, right? This is right. It's a 90 degree.
3 by 5.
Because
3 by 5.
sorry. Yeah, correct. 3 by 5.
3 by
It's a 3 by 5. Yeah, 3 by 5. So you need to be careful. Like you need to first identify this right angle, because for right angle opposite to the alpha 1 or this angle should be right angle, right? Because uh, maybe even some other cases, maybe some other side, maybe even right angle. So you need to be careful with this pictures. Approximately, you try to estimate these things. Okay, you know, because this is radial distance. 4 is the radial distance, right? So this will be 90 degree. So cos alpha 1 is 3 by 5. So cos alpha 2, or you can say, sorry, you can calculate alpha 2. What is alpha 2? This is alpha 2. I can go below this. What is alpha 2? Observation point, and that source or upper edge of the wire is at infinity, right? So what will be the angle? Alpha 2 will be 0, right? So cos alpha 1 will have calculated, that is 3 upon 5, right? Cos alpha 2 will be cos 0 will be 1 now, right? So cos alpha 2 will be cos of 0, 1. Now other part of the question is A5. So A5 is AL cross A rho, and the current is flowing in which direction? So that will be represented by A, that is AL vector. So what is AL vector here? What is AL? What is the direction of, in which direction current is flowing? This is along the positive X direction. So this is Z, this is A, Y, this is X. It's in the corner of the slide. It is positive X. It is going in this direction. It is positive X direction. One part is done. Now other is A rho. What is A rho vector? At least you tell this answer. What is A rho vector? So this is rho. This is the radial direction. Rho equal to 4. So this is the radial direction. So A rho is along the Y direction. AY. Good. AY. Right? Now let me only highlight this part. So A5 is AL cross, sorry, A5 equal to AL current flow direction multiplied with the radial vector connecting the source and observer. Current is flowing along the positive X direction, and the radial direction is along the positive Y direction. So the magnetic field should be along the positive Z direction. Now let us check why it is along the, whether it is correct or not. So if you consider this wire, green wire, and if you keep with your right hand, then magnetic field lines will go like this way. In this direction it will rotate. Okay, as observer is somewhere in this point, right? So it is like, I will highlight here. As the current is flowing in this direction, magnetic field should be in this direction. So observer is here, somewhere there. Okay, so with respect to observer, magnetic field lines are passing in this direction. It's related to the observer. Okay, relative is here. So with respect to the observer, magnetic field lines are going in this direction, passing in this direction. Okay, so that's why the answer is Z. It is Z, right? So it is positive Z. So in my, sorry, I think I took extra 5 minutes today. So if any questions, please stay back, or else you can leave. I will upload. I have already uploaded the slides, required slides. Maybe you can stay for one more minute. I will I want to talk something about this CAT2 exam. So CAT2 exam question will be from post Gauss's law. So after Gauss's law, we have magnetic vector, sorry, scalar vector potential V, right? Where we have this relationship, right, equal to negative grade of V. So this is one topic, and in attachment to this topic, we have topic for energy. So this is a major topic. And moving to the other topic, boundary conditions. So you will get surely one question from the potential and one question from the boundary condition, and other possible questions will be from the boundary value problem. Boundary value problem, maybe Laplace or Poisson based. You will get one question. You will get 10 mark with this. Maybe 10 or may not be less than 10 for boundary, because it's a quite simple question you may get. But boundary value problem, you will get 10 mark question. And the fourth possibility is this Biot-Savart's law. So it's going to be a compulsory question. It may be 5 to 10 mark question. Biot-Savart's law based. Thanks for joining. You can leave now.
Thank you, sir.
Thank you.
During preparation, if you have any doubt, you can send your doubts and clarify through the Teams chat. Don't send WhatsApp or email. You send your questions or the doubts. You write it in the paper. You take it as you share the picture so that I can understand the problem. Because it's difficult to type the things, so better you use your paper and wherever you got stuck, maybe in the numerical or derivation, you can write it in paper and share that view in Teams. I will reply there.
Thank you, sir.
Thank you.